Just a note before we get into today's episode. Our story today is about forensic science, focusing on the crucial but emotionally heavy process of identifying human remains after environmental disasters. There's really interesting science here, but it's not for everyone. So if you're not feeling forensic science today, hit pause and check out one of our other episodes. You know, like the one about bananas or a firefly's getting it on. Those are good ones. Okay, let's get into it.
I know, I can see it.
December 26, 2004.
That wave is a good 15, 20 feet tall. Easy. Get in!
Just before 8 o'clock in the morning, in the middle of the Indian Ocean, a tectonic plate miles below the ocean floor slips and triggers one of the largest earthquakes in recent memory.
The disaster is unfolding. We now know the wave was triggered by the world's strongest earthquake in 40 years.
The earthquake registers over 9 out of 10 on the Richter scale and releases an amount of energy equal to approximately 23,000 atomic bombs. Moments later, the force from the earthquake causes water to displace, and a tsunami begins making its way towards the surrounding coastlines of several countries, including Indonesia, India, Sri Lanka, Somalia, and Thailand.
The waves, they estimated in some areas, were maybe 30 meters high. And so when these waves hit land, it rushed inland and basically devastated structures and took many, many human lives.
In the aftermath of an event like this, help is needed in many ways. First responders, government officials, and teams of scientists. Disaster victim identification, or DVI, is the process of using science to help identify the people who are lost in a disaster and inform loved ones who are waiting for answers. So how does this work? How do we even begin to match names to the victims? What technologies do they use? And how are genomic tools helping to bring families closure faster when the unthinkable happens? You're listening to Nice Genes, the podcast that weathers the scientific storm to bring you answers. I'm your host, Dr. Kaylee Byers, your forecaster into the world of genomics. As climate change shapes our world, we're bombarded with news about extreme climate events.
Hurricane Milton, it exploded from a Category 1 storm into a Category 5 in just a matter of hours. The reason for this rapid intensification, well, it appears to be climate change, and it is likely a disturbing trend when it comes to future.
These events can often displace thousands of people and sadly also take many lives. Locating, analyzing, and identifying victims of these events is a huge undertaking. If a person can't be identified by things like a piece of ID or jewelry that they were wearing, we need to turn to forensic science to make a DNA match and figure out who the remains actually belong to. This can be through fingerprints, bloodstains, or possibly the most reliable option.
Dental historically has been the number one method of identification in DVI events.
Looking at those pearly whites. So, to help us sink our teeth into this fascinating field of forensic odontology, here with me is Dr. Dirk van der Meer. Can you tell us a little bit about your role as a Chief Forensic Odontologist for the province of British Columbia?
So I basically act as a liaison for the forensic odontology group that we have in the province. I'm the president of the Forensic Odontology Response Team BC Society, or Fort BC as we're called, a group of volunteers. And as the president of that society, I also take on the role as the liaison with the BC Coroner Service.
So what is forensic odontology and when do we use it?
Forensic odontology is also called forensic dentistry. So it's that aspect of dentistry basically that overlaps with the law. So the areas of forensic odontology that are most common are the identification of human remains using their dental data, dental information. It could be the estimation of age, especially in children or the subadult when teeth are developing. It's one of the most accurate methods of determining how old someone might be. bite mark analysis and comparison. There's also an area of jurisprudence where a forensic dentist may be asked to testify in a court of law in a case on work that they've done.
Why are teeth so important in helping to identify victims?
So when human remains are found and they are unidentified, the teeth are the hardest substance in the human body. They can withstand extreme conditions, cold, heat, fire, time. And within those teeth are unique features that can help to identify that person. We're talking generally fillings, restorations in that, but there are some natural anatomic features that can be used as well. So those features sometimes will last and be there in good clinical form, even though the rest of the body may have decomposed.
And you also use DNA for part of that process. So what makes teeth a good source of DNA?
Teeth are uniquely connected with DNA in the forensic identification process. And there's really two aspects of that. Number one, within teeth, there is pulp tissue, soft tissue, the nerve, and that contains neurovascular cells, which are rich in DNA. And even teeth that have had root canal treatment, so the nerve has been taken out, there are still tiny cells, odontoblasts, which are cells that make dentin, and they get trapped during the formation of teeth. And so all of these cells and the pulp is encased in a hard shell of enamel and dentin and cementum, so it is protected. So it becomes a rich source of DNA even when there are no other good sources left in the body.
Interesting. So teeth are valuable in two respects. Like one, they can look at what dental work you've done, and then they can also look at the DNA, and they can grab that from a number of sources in the tooth.
Exactly.
I like to open water swim, so I'm projecting into worst case scenario. There'll be in case my remains are ever found off the coast of Vancouver. There are some options.
Go to your dentist first of all.
Yeah. So we're going to shift a little. 20 years ago, there was a tsunami in Thailand. And we want to talk a little bit about that because you were involved in the process of disaster victim identification. So can you tell us about what happened in 2004 and why the government called in additional help?
So it was Boxing Day, December 26th of 2004, when there was an immense earthquake in the Indian Ocean just off the coast of Indonesia, approximately 9.2 on the Richter scale, which is incredible. This set up huge wave ripples concentrically in all directions. And the waves, they estimated in some areas were maybe 30 meters high, 100 feet. And so when these waves hit land, and there were many countries were involved, it rushed inland and basically devastated structures and took many human lives. The estimated death toll, and they can never know for certain, but it's somewhere in the range of 250,000 people.
Fact checker coming in here because I can't resist. We looked into this. The number of deaths seems to be closer to 230,000, but it's really hard to say. But regardless, it's one of, if not the deadliest natural disaster of the 21st century.
In Thailand, they estimated approximately 5,000 people had died. And of those, approximately half would have been Thai nationals, and the other half would have been foreigners on vacation. So as you can imagine what it would have looked like with all of the infrastructures decimated and 5,000 bodies everywhere, they realized quite soon that it was too much for the local authorities to be able to handle this whole situation, especially the identification of the victims. So the Thai Royal Police have jurisdiction in that area for identification of the human remains, and they approached Interpole, International Police, and asked for assistance. And the lead forensic odontologist Canada at the time, David Sweet, put a team of forensic dentists together, and I was asked to go. He literally tapped me on the shoulder and said, for the tsunami, we're sending a team over. Would you be interested? I said, absolutely. Tell me when. Our team had trained quite a bit for that. We've done many cases, so we were well prepared to do it. This is what I'm trained for. I wanted to help. And so it was just a matter of waiting for my turn. And it ended up being the largest DVI response in the history of the world.
During your time there, was there a moment that sort of really moved you where you sort of felt the human impact of what this event meant for people there?
They built a temporary morgue in an area in Phuket, which is quite a large compound. And the entrance to the compound, they built a wall of remembrance. And each section was dedicated to a country that had lost some of their nationals. Canada was on there. And on that wall, family and friends would put memorials. There would be teddy bears, there would be flowers, pictures, lots of pictures. One in particular I remember was at Sweden, and it was a drawing done by a child. And it was obviously two young girls. And all it said was, "my sister," with an exclamation mark. And of course, I have two daughters and they were at home. So that was something I always remember.
Can you talk to us about some of the logistics? So in such a chaotic event, so many teams working together, but all working on different things. How does it work? How does it all run somewhat smoothly?
It's a beehive of activity for sure. There were essentially two sites by the time I got there. One was the postmortem morgue, and teams from all nationalities worked in there. What they would do is the remains were in cold storage. They would wheel the remains into the one end of the morgue, and it would go through an assembly line of specialists. So there would be people who would take personal effects and take photographs. There would be a pathologist, and maybe the pathologist was from Indonesia. And then there would be a DNA specialist, and maybe they were from, I don't know, Australia or New Zealand. And then the next stage could be fingerprints, and then would finally get to the dental, which was us. And then the other site was in an office building. And that's where all of the antemortem records were kept. First of all, antemortem being before death. So these would have been the dental records from the missing persons or the fingerprint samples from missing persons. And it was all together in one area. And also that's where we did reconciliation, comparing the antemortem and the postmortem to try and make identifications. And this is all spread out through a couple of floors of a fairly large office building in Phuket. Spent a lot of the time in front of the computer because all of the data was entered into an Interpole software. But all the data, whether it's dental, fingerprint, DNA, personal effects, anything about the missing person goes in one database, everything about the found remains in another database. And then they ran comparisons to try and narrow down who might be who.
In this kind of event, can you walk us through the different ways of identifying remains?
Dental historically has been the number one method of identification in DVI events. But as DNA has evolved over time, it's gotten faster and it's gotten cheaper, and smaller segments of DNA are needed for identification. But Interpol recognizes three scientific methods for forensic identification. DNA, of course, is one, dental is the second, and fingerprints are the third. So those are the three primary identifiers, they call them. And it was not uncommon for one set of remains to be identified by all three.
Right, okay.
And sometimes DNA couldn't be possible. Perhaps there was no antemortem DNA. Maybe the person was adopted, for example, and there were no blood relatives to get DNA from, things like that. Or some people had no fingerprints at all that they could use for comparison. And so dental might have been the only case.
So in an ideal situation, you'd sort of have multiple methods to be able to confirm that is this person, but sometimes you're just using one.
Well, in the absence of all three of those, which was rare, but it could happen, there are other secondary methods. Tattoos can be used, medical appliances, that type of thing can be very helpful in making the identification.
Let it be known, I have a jellyfish tattoo on my left foot in case it ever comes to that. Okay. Just so you know. You mentioned how, with advancements, you need less and less DNA, and certainly, things are changing so quickly. So, in your view, how important are scientific and genomic advancements in improving DVI processes?
They're vital. They're incredibly important. Rapid DNA is something that's on the rise now, where DNA profile within a number of hours potentially, but there are limitations to that, especially with samples that are partially decomposed or in advanced decomposition. But the DNA experts that I've heard from tell me that it can be useful in some situations, but it's one of those things that is continuing to evolve, continuing to be faster and better. And so I would expect that would continue to be a very important part of the DVI process.
We can see that rapid instruments would help us reduce that identification timeframe so families can have their loved ones back sooner.
Coming up, we're off to the land of Oz, where we'll step behind the curtain to uncover the magic in the lab.
The great Oz has spoken.
You're listening to Nice Genes, a podcast all about the fascinating world of genomics and the evolving science behind it, brought to you by Genome British Columbia. I'm your host, Dr. Kaylee Byers, and we want to get more people to listen to the genomic stories that are shaping our world. So if you like Nice Genes, hit follow on Apple Podcasts or wherever you get your shows. Don't forget to share it with a friend and give it a DNA Plus review.
My name is Dadna Hartman, and I'm the manager of the molecular biology lab at the Victorian Institute of Forensic Medicine. And our lab is tasked with assisting in the identification of deceased persons for all coronial cases that are reported to the coroner here in Victoria. I joined the laboratory in 2008, just prior to the 2009 Victorian bushfires. So I guess for me personally, that's been my biggest experience with a DVI event. And it was considered quite a large-scale event for us here in Victoria and Australia.
Dr. Hartman leads a small team of scientists where they analyze DNA from victims and compare it to samples from their families in order to make a connection and confirm the identification of the deceased person. And that DNA can come from a number of different sources, like bloodstains, bone fragments, and even bladder swabs. When these samples are in decent condition, meaning they haven't decomposed too much, they might not need all the fancy lab tools to identify who the sample belongs to. Instead, they can use a genomic tool called Rapid DNA. These instruments are portable devices that can quickly analyze a DNA sample and generate a genetic profile on the scene. No lab required. And Dr. Hartman has investigated just how useful this tool can be.
What we wanted to see with our own hands, if you like, how well those instruments performed with the sample types that we see routinely and that we would expect to see perhaps during a DVI event. So things like not just a pristine blood stain, but perhaps a decomposed blood stain, a toenail clipping. So all the samples that we might see routinely, how would those instruments fare? Because in a DVI event, you could potentially take these labs in a box, if you like, with you and be processing samples at the site. And the idea being for us was that we could potentially be processing the more pristine samples, the ones that work relatively well with these new instruments, to free up the lab to concentrate on the more difficult ones that don't work on these sorts of instruments. And you don't require a high level of training to be able to do that. The instrument does all the work. So it does the extraction and DNA profiling all within that cartridge, and then it outputs the DNA profile.
It takes about 90 minutes to take a DNA sample, do a little this, do a little that, and run it through the Rapid DNA instrument. During that time, those on the scene can continue their work while the machine is doing its thing.
We can see that perhaps where you're setting up your interviews with families at a DVI event, where you're collecting your antemortem information, while you're doing that, you could be collecting a sample, processing it as you're interviewing them, so that by the time you collect all the antemortem information about, the missing person, any, medical conditions they had, any identifying features, all those details that you capture as part of the DVI process, by the time you do that, you could have a DNA profile ready to go for that missing person. And I'd imagine that it means that the turnaround times for reporting those identifications is improved. Therefore, family members have access to the loved ones in a more timely manner.
I can only imagine how during a time like this, where you're waiting to hear news about a family member or loved one, every second counts. And these tests help get people that information sooner. But as we said earlier, DVI is a whole beehive of activity.
Matching or DNA profiling is just one component of the DVI process. So although we can potentially improve the DNA reporting timeframes because we're using better instruments and we can do things quicker, it doesn't necessarily then translate to the DVI process being completed.
Once they have that DNA profile from the Rapid kit, it goes into a process where all that evidence gets bundled together. DNA, other bits of information, all goes into a report. And that report gets handed over to the coroner, who still has to review everything and officially say,
yes, I take this evidence on board and I agree that this individual can now be identified. So we try to streamline as best we can, feeding that information into that process, but that still takes time to go through those steps that need to occur before an individual can be released to the families.
So the entire process still involves several steps and checks. But even with those limitations, these instruments are making things easier. That said, identification relies on having a DNA sample from a family member for comparison. So what happens when we don't know who those family members are?
We are evaluating the application or use of forensic investigative genetic genealogy, which is a mouthful, or FIG for short, for the identification of long-term cases that we have where we've reached the end of the line, and FIG might be able to be used to identify these individuals. And it relies on being able to find more distant relatives using publicly available genealogy databases. Now, this is not something that you would use routinely for a DVI event, let's say, for example. However, you may have a scenario, and I believe this did occur in a case in the US where they have a victim of bushfire, for example, no idea who this individual may be. All avenues to try and identify this person have not resulted in identification. What can you then do to try and identify this individual? And FIG may be a way to be able to identify these people where we actually have absolutely no idea who they are.
Even with genomic tools making things a bit easier, the emotional weight of this work is still heavy. And it's important that those who are working in this space, like Dr. Meer and Dr. Hartman, think about their own mental health too.
It's very difficult to go home at the end of the day and see the news and see reports of the various victims and their families and their lives. And all of a sudden you're making connections between names and people. So it's kind of how do you disconnect from that in order to do your job and do it well. So there are little things that you can do to look after your team and also ensure that everyone is well. I think we did that quite well after the bushfires. We made sure that as a team we could debrief all that emotion that perhaps you're holding on to while you were doing the science bit that you have to process as a person. And we worked really hard, but we worked kind of normal hours. People went home and rested and had a break and, went home to their families. And it's sort of, that balance of being able to kind of switch off a little bit from that intensity and then come back the next day and do it all again. Personally, it's a real privilege to do what we do day in and day out, whether it be a standard coronial cases or a DVI event. It's being able to provide families with answers. So for us, that's what we come in every day to do.
It's so clear that for everyone in this field, there's a deep understanding that every DNA sample connects to a person with their own story. It's tough work, no doubt, and it goes way beyond just the science.
While we were in Thailand, a Canadian had been identified, an adult male. Now, we were part of a team that was RCMP, dentists, and some members of the Canadian Embassy. So the Canadian Embassy does liaison with Canada and with the family, and the family said that their son would have liked to have been cremated and ashes spread in the sea. So about 5 or 6 of us took part in the ceremonies at the Buddhist Wat where the cremation took place. And that was quite a moving experience, sort of surreal experience. And then the next day, we rented a small boat, a 26-foot boat or something, out to the Andaman Sea and in a small ceremony, the 5 or 6 of us, and spread the ashes into the sea, the very same sea that took his life as well. But it was moving for us. And I also was quite taken aback at how well the Canadian government and the embassy took care of this one Canadian who lost his life.
Yeah, that's a really beautiful story.
Mm-hmm.
I mean, very sad, but
yeah,
very beautiful to be able to be a part of that.
Mm-hmm. Absolutely, yeah.
The tsunami of 2004, we hope, is like a once-in-a-lifetime event, but climate change is making these large natural disasters. I mean, they're happening more frequently. And thinking of that, what do you think are some of the most critical areas of development for DVI moving forward?
It comes with not just the science of the identification process, not just the DNA, not just the imaging and that, but it does come with a lot of the logistics. There's the unseen thing that happens in a DVI situation. How do we get people there? How do we make sure they're safe? How do we make sure they're housed and have water? And these are the workers, the scientists, the boots on the ground that are working in that environment. And that's something that is continually an important subject and continually evolving. And you're right, there are natural disasters happening at more frequency than before. We had the Maui fires just over a year ago, and that was an American DVI response that took 100 lives, I believe, and that was quite devastating. The one thing is, in my field, as a forensic odontologist in British Columbia, for years I've been part of this forensic odontology response team, and we train and we do identifications for the coroner service, where we run training sessions for international military. We did extensive training on DVI. And yet we do all this in the hopes that we never actually have to do it. We never actually have to be deployed. So if I never go to another large-scale mass disaster in my life, I will not be disappointed.
Thinking like you're saying, you're training in case, but you hope that something like that doesn't occur again. What drives you to continue working in this field?
To be honest, I don't exactly know, except that I'm fascinated by it. And I always have been fascinated by it. I've been always fascinated with science, which is why I went into science. I was fascinated with health sciences as well, so I went into dentistry. And then when I got one taste of what forensics was about, I was hooked. There are many people that I deal with internationally who say the same thing. Not sure why they do it, but they're just so fascinated by it that they continue to do it and continue to donate time and effort into the learning process.
Is it a real cocktail party conversation starter or ender? Which of the two?
So, it's funny. I meet two types of people: those who are absolutely fascinated by forensics and want to hear all the stories, and others who are completely turned off and don't want to talk about it at all. So I don't talk about it too much unless someone brings it up. But then if I start talking about it, I just don't shut up. It seems I could talk forever about forensics. It's a fascinating field.
Well, Dr. van der Meer, thank you very much for your work and also for your time. This is really interesting, and I appreciate it.
Thank you so much. I appreciate the invite.
No matter the rain, no matter the storm, I'm coming home. I'm coming home.
Our guests for today were Dr. Dadna Hartman from the Molecular Biology Laboratory at the Victoria Institute of Forensic Medicine and British Columbia's Chief Forensic Odontologist Dr. Dirk van der Meer. You've been listening to Nice Genes, a podcast brought to you by Genome British Columbia. If you like this episode, go check out some of our previous ones wherever you listen from. Share us with your friends and leave us a review. You can also DM the show on social media by going to @GenomeBC. While we can't always control what's going to happen, being prepared is key. Next time, we're getting into the deer tales of a disease that's threatening the health of deer, elk, and moose across North America.
This isn't like a lot of the other pathogens that are on the landscape. These prion diseases are not naturally occurring in the environment. And with chronic wasting disease, unfortunately, there's just an increasing trajectory of the number of cases, and animals don't recover.
Thanks for listening. We'll be back with a new episode faster than you can say Rapid DNA.